Hi there, Mrs. Pesic here. We are looking now at absolute value functions and transformations. And if you need more assistance on this, this is in section 2.7 of your book. After completing this section, you don't need to write this down, but after completing this section, you should be able to graph absolute value functions by hand and by calculator, write an absolute value function if you are given a graph, and perform a transformation for any function, and use absolute value functions to model real-life situations. All right, so let's look at some examples of absolute value. First of all, if you are familiar with absolute value, then you know that the absolute value of 4 is 4. And why? Because 4 is 4 units from 0 on a number line. So absolute value means distance from 0 on a number line. What about the absolute value of 0? Well, how far is 0 from 0 on a number line? It's 0 units. All right, and what about absolute value of -5? Well, that's going to be +5 because -5 is 5 units from 0 on a number line. All right, so here's our definition of absolute value. It goes like this. Absolute value of x is equal to the same number that's inside the absolute value if that number was positive to begin with. The absolute value of x is equal to 0 if x was 0 to start with. And the absolute value of x is equal to the opposite of x if x started out as a negative number. So for example, like in this last example, we had the absolute value of opposite of 5, and that means the absolute value of opposite 5 is equal to the opposite of that number that was in the absolute value. So that's the opposite of -5, which is +5. All right, now let's talk about graphing. If we wanted to graph f of x equaling absolute value of x by plotting points, I have some points plotted or some points ready to go here. So for example, if we plug in -3, then the absolute value of -3 is a +3. And that means we would have this point right here at -3, +3. How about the next ordered pair? -2, absolute value of -2 is +2. So that gives us this point right here, -2, +2. What if it's -1? The absolute value of -1 is +1, so that would be this point right here. How about 0? Absolute value of 0 is 0. What if it's the absolute value of 1? Well, then it's just going to be 1, so we get the ordered pair 1, 1. Absolute value of 2 is 2, so we get the ordered pair 2, 2. Absolute value of 3 is 3, so we get 3, 3. So in general, our equation is going, or our graph is going to look like this. It's a nice V shape. Every absolute value will be a V shape. All right, and I do want you to notice that if we have an absolute value, it has a vertex. That vertex is always like the point of the V. So in this case, the vertex is at 0, 0. All right, so for your notes, let's make sure we're understanding. The parent function for absolute value functions is what we're looking at. All right. And the parent function for the family of all absolute value functions is f of x equaling absolute value of x. Okay, the graph of this function is V-shaped, and it is symmetric about the y-axis. That means it's a mirror image from one side of the y-axis to the other. So every point xy on the graph, there's also going to be a point opposite of xy. So, for example, -2, 2, and +2, 2. They're mirror images over the line y equals x. Notice to the left of x equals 0, the graph is given by the line y equals -x. To the right of x equals 0, the graph is given by y equals x. The highest or lowest point on the graph of an absolute value function is called the vertex. That's the point of the v. And for our parent function, f of x equaling absolute value of x, that's going to be 0, 0, as we saw in the previous example. All right, you can derive new absolute value functions from the parent graph by transformations. A transformation changes a graph's size, shape, position, or orientation. A translation is a transformation that shifts a graph horizontally or vertically, but does not change its size, shape, or orientation. So a translation is a type of transformation. Again, feel free to pause this video at any time so you can take these good notes. All right, so what if we wanted to graph f of x equaling absolute value of x plus 2? Let's test this out. If we plug in -3, we get -3 plus 2. Absolute value of -1 is 1. So we get the order pair -3, 1. How about if we plug in -2? We get -2 plus 2 inside the absolute value. That's the absolute value of 0. That's 0. So we get the order pair -2, 0. That's right here. I hope you're graphing along with me on graph paper. You do need graph paper for your notes. If we plug in -1, we get absolute value of -1 plus 2. That's absolute value of 1, which is 1. So we get the order pair -1, 1. Absolute value of 0 plus 2 is absolute value of 2, which is 2. So at 0, we're at 2. And if we try plugging in just a couple more, absolute value of 1 plus 2 is absolute value of 3, which is 3. And absolute value of 2 plus 2 is absolute value of 4, which is 4. So that means I can plot 1, 3, and 2, 4. Notice we are getting a graph that is shaped like a V. Obviously, it's going to keep going up, 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 up in this direction also. All right, so you get the idea that it's been shifted from our original graph, which was not on this page, from our original graph, which had a vertex at 0, 0. Here was our original graph, looking something like this. But now our new graph has been shifted over 2 units to the left is the shift. All right, so just so you notice that, this was f of x equaling absolute value of x plus 2. And what did we notice about this? This was a shift 2 units to the left. And that may not have been what you were expecting, because if we see a plus 2, we're probably thinking it's going to shift to the right, but instead it gave us a shift to the left. So absolute value of x plus 2 gives us a shift 2 units to the left. All right, we're going to skip this graphing calculator activity. We're going to do that in class. All right, so what about these transformations? You can perform transformations on any graph, not just absolute value graphs. And so here's the deal with this. If f of x is your original, then y equals f of x minus h is going to shift the graph h units to the right. And f of x plus k is going to shift the graph k units up. A times f of x is going to stretch or shrink the graph. And a times f of x is also going to reflect the graph over the x-axis if the a is less than 0. Okay, I'm going to stop this at this point, and we will take this up in the next video. Thanks for watching. Hope you took good notes. Please write down 3 questions that you have also. Thank you. Have a good day.